Hello everybody and welcome to the teacher manual version of Savas Algebra 2, topic 3, lesson 6, example 4. In this one we're going to look at irrational roots and coefficients of polynomials. And this is just a conceptual understanding. So if you understand it from the book, then that's perfectly fine of the notes that I uploaded. But remember that if r is a zero of a polynomial, then x minus r is a factor. So what they say here is if you have, and this is what I've been doing in the past, if you have x equals some value r, and we have a positive heart here, to get the factor, we're going to subtract r from each side and set that equal to 0. And thus we're using the zero product property, because then we can see each factor that's equal to 0 that gave us that polynomial. And again, if this is x equals negative r, then this is x plus r is going to be our factor in this case. So let's look at this. Let's look at what they're saying here. Let me clear everything up. And I do have b off to the side. I'll move it to the bottom of our work. I just wanted to make sure I had enough room to write. As you guys who watch my videos know, I write pretty big. So there we go. So suppose that a quadratic polynomial function p has one rational zero c. And one irrational zero, a plus b, the square root of b, where a and b are rational numbers and are coefficients. So again, the square root of b, that will go on forever. Like the square root of 2 is like pi. It really has no end, and that's why it's an irrational value. So the square root of b happens to be something that is not a perfect square. Are all the coefficients of p rational? All right, so write p of x in terms of the factors. So p of x is going to equal, we have one factor, x minus c, because we have a rational zero of c, which means x is equal to c, and one rational zero of this guy. So we're going to subtract a plus square root of b. All right, so what we're going to do now is we're going to multiply. We're going to FOIL this out. I'm going to cheat this a little because I know that I'm going to be adding these two and then multiplying these two. This is my p and my q from when we were doing factoring. When we think of two factors that multiply to give me c but add to give me b, I'm going to use that same idea. I'm just going to add them to get me my b coefficient. So negative c plus negative a plus bi is going to be a negative a plus b plus c. So I'm going to put the negative on the outside because, again, you're just subtracting them all. And then x plus, basically I pulled out the greatest common factor of a -1 when I did the subtraction there. And then we have a plus square root b times c for this one right here. So it looks like even after multiplying and adding this out, we still have the irrational values. We still have the root b here, and we still have the root b here. They're not going away. It has not gone away. But let's keep trying. Maybe if we keep going, we'll get something here. So x minus a minus root b minus c. Oh, these are all x's. Ax minus x root b minus xc, cx, coefficients always first, plus c a. No, we still have the irrational. There's nothing that cancels out. So no, the function of p has two irrational coefficients. It's 2 irrational coefficients. No way I could get around that. That's just how it's going to be. All right, so let's go to B. Suppose a quadratic polynomial function R has 2 irrational zeros, a conjugate pair of a plus b and a minus b. Again, the conjugate meaning that these two are the same. The only difference is this operation here, where a and b are rational numbers. Are the coefficients of R rational? So are all coefficients of R rational? Let's see this. R of x equals x minus a plus root b times x minus a minus root b. All right, now let's look at this. We're going to FOIL this out. Again, I'm going to use that idea that the b coefficient is going to be these added. The c's coefficient is going to be these multiplied. So we have x, x times, let's see, x minus a plus root b plus a minus root b. Because we have the negatives here. That's going to be the minus. X, negative times negative is positive. A times this, so that's going to be a. This is a conjugate, so this is going to be a minus b. All right, now looking at this, we're going to look at the middle terms, and these actually fall out. So we're going to have here the middle terms falling out. So we're going to have x minus, this cancels that out. So x minus 2a, x plus a minus b. Oh, sorry, this is a squared because a times a is a squared. And that's it. We have no roots anymore. So yes, R has only rational coefficients. And there you go. All right, these are just conceptual ones. It's looking to see what would give us irrational or rational values. So I hope you guys have a fantastic day, and hopefully Sevis will be working soon. We'll see you later.